Hi, everybody. Thank you so much for joining us for today's Seal Connect webinar on food and beverage case studies. We primarily focus on food in this one, but the technology we're talking about can be applied to food and beverage. And Zach, thank you so much for being here with us today to present. Well, as we wait for attendees to come in and join us, I wanted to ask you a question about your toughest or most problematic food case study or application that you have had to deal with in your fluid sealing time.
It's definitely the chocolate. It's not quite like Willy Wonka and the Chocolate Factory. It's when you go into a chocolate, looks like a mudslide everywhere. There's chocolate all over the floor because it leaks out of their conches, their agitators, their mixers, their blenders, and usually gets collected in 5-gallon buckets that overflow. And so that's a major issue where they're not only losing product, but they're and valuable product, chocolate. Everyone loves chocolate, but they're creating quite a mess for risks for slips and falls. So there's definitely safety issues that get caused with that. And so the chocolate industry, I mean, one of the things that we did early on with the air seal was seal up a number of those applications that saved a lot of chocolate. So everyone should be happy. We're doing the world a favor just on that alone.
Sounds great. Again, thanks for joining us. We're going to move into the next slide and talk about some housekeeping issues for you who are attending today. This is our Seal Connect Classroom webinars, and we have started doing these educational trainings just to help end users and anyone else who might need it get some technical information about different sealing technologies and also just reliability in general. You can join our chat on social media by using #SealConnect. Please use the question tab on the sidebar of GoToWebinar to ask any questions at any time during the presentation. We will answer most questions at the end unless I find one super important to answer at the exact moment. And I'll interrupt Zach and ask. Otherwise, we will ask all of your questions at the end of the presentation. The webinar is being recorded, and we will send the webinar and the webinar recording and a copy of the PDF slides to you within 24 hours of the end of the webinar. Also want to let you know that in the sidebar of GoToWebinar, there's a handout section. There are 3 handouts there if you would like to download those. That just gives you a little more information about some of the case studies and applications we will be discussing today. And again, ask questions now. Enjoy the webinar, and I'm going to hand it off to Zach to move forward with the presentation.
All right, hello everybody. I'm Zach Neppa. I'm the regional manager for SEPCO in the Northeast. I'm also a product manager for the air seal. And today we're just going to discuss how to eliminate leakage that causes downtime and safety issues in food and beverage plants. And next slide.
Are you able to see the slides? Everything still okay?
Are you asking me?
Yeah.
Yes, it's on the same slide.
It should be on the agenda.
Oh, it says food and beverage case studies on mine.
Okay. I'm not sure why the slides aren't advancing for you. Let's see. If any of our attendees could add, if you're seeing the slide that says agenda, we'd appreciate it. And if you're not, let us know that too. You can do that under the question section for me if you want. or the chat. We apologize for the technical difficulties, but this is a live event, and so that's what happens sometimes.
Yep. Thank you for your patience.
Yes. So you're still seeing the opening slide?
Yes.
Let me hop out and start presenting again and see if we can't fix this. Sorry, folks. And I'll try to stop sharing and share again and see what happens. Any difference?
Okay, so today we're going to talk about powder and slurry applications that cause problems in the food industry, the seals that we've installed on equipment, and why air seals are see success in the food industry, and then we're going to discuss some case studies of actual applications that we've sealed. Next slide. Is it going? There we go. And then we have a poll. Not sure where everybody in here comes from, but if you have equipment, you're sealing it some way. And this poll, just if you answer that, it'll give us an idea of what you're using now, and we can use that to compare.
So yeah, I just launched the poll. So please answer what seal technology you are currently using in your applications. And I see people answering, so that means you can hear us, which makes us very happy. And give you a few more seconds to answer. And then we will close the poll and talk about the results. And we have 100% are using compression packing, 100% are using mechanical seals, and 50% are using lip seals. No one is using air seals currently, so that's great information. I'm going to put the results away, and hopefully, Zach, you will be able to see the next slide, and we'll go from there.
Yep. Okay. The food industry applications require high-functioning seal technology, lip seals, compression packing, and other sealing components that touch the shaft often allow pathways for leakage after a small time of operation. So what we mean by that is lip seals and mechanical seals and packing, they all have their place in industry, and are at SEPCO, we apply them in a number of applications. But in the food industry, it's very, very tricky, because with mechanical seals and packing, you need some form of lubrication to lessen the friction. So oftentimes in industry, that's flush water that would be used. But in the food industry, you would be adding that to the ingredient, to the actual food itself, and therefore they have to run dry. Now, when these sealing solutions run dry, they create friction and create heat, which eventually creates wear on the shaft, and that wear eventually leads to a leak gateway, if you will. And as it leaks, it just becomes a constant cycle of maintenance and cleaning and downtime, which creates safety issues and product loss. Now, with that wear on the shaft that is created by leakage or by friction, excuse me, that it cannot be improved over time without upgrading the shaft with either a sleeve or just replacing the shaft altogether, which gets expensive, creates downtime, and sort of creates just an endless cycle of maintenance and cleaning. And that's where the air seal comes in with non-contact technology that won't wear the equipment. So that cycle is broken. Okay. Now the air seal, which is what we're going to focus on today, is a non-contact seal that uses air or gas, whether it's nitrogen, any form of air that's allowed in the process. What it does is it it creates a pressure barrier without creating contact, and that pressure barrier is what forms the seal. You can go to the next slide. Okay, and today we're going to discuss how it actually works. It's very, very simple. You can see this cross-sectional design here of the air seal. And what happens is at the air inlet, if we're looking at the very top of the image, air is received by the seal. And then what it does is it's delivered to that floating air throttle in the center and harnessed, and it builds a back pressure. And that back pressure creates a barrier inside the seal that, as long as the pressure delivered to the seal is higher than the head pressure at the sealing location, which is typically low in the food industry because most mixers and blenders and conches are basically open, not pressurized vessels, that air will form that barrier and hold back whatever product is inside that application. So we discussed chocolate, but this also works on dry powders as well, a number of any other foods that you can think of. And what it'll do is it'll just keep it inside the application. And then what the air does is it doesn't stay inside the seal, but it's harnessed, and it leaks out at a very low rate, just to relieve pressure inside the seal, because it wouldn't be able to hold pressure forever. It has to relieve that pressure, and that pressure release doesn't allow product out, and it also protects the food from the atmosphere as well. So if you were getting contamination via the stuffing box, it'll keep contamination out of food, which is extremely critical because you cannot sell contaminated food. Furthermore, you see that throttle internally, the green piece, that throttle internally, as the shaft moves. So if there's shaft deflection, which is very common as well because you have large shafts and uneven batches within mixers, that what happens is that throttle actually floats with the shaft. There's a pin. If you look in the top right hand corner of the green section of the image, you see a pin that connects the throttle with the air seal. What that does is it prevents it from spinning, but it also allows it to pivot with the shaft as the shaft moves. So this is a major issue. If you were to have packing or a mechanical seal, what shaft movement would do is damage both seals and create a new leakway. Like with a mechanical seal, it would actually do damage to the seal. With packing, what it would do is compress the packing, and the packing doesn't have a memory, so it won't come back with the shaft, and it creates a clearance for product to leak out. Next slide. Now here's an analysis of, this is a very common question, is how does the air distribute itself? This is a cross section. If you were to take the throttle and look at it, there's holes on the outside of the throttle that receive the air, and they have essentially pathways from the OD to the ID that deliver the air to the OD of the shaft, and as well as around the OD of the throttle. So basically the entire cavity that is created inside there is purged with air. It's pressurized, and from there it won't allow anything to cross. And you can see here how evenly distributed it is. This is an analysis that we ran of the distribution of the air. So the air is very evenly distributed and balanced when it is delivered to the throttle. Next slide. All right, and here's another poll for everyone to answer. This could help us narrow down and help you select seals better.
All right, thanks, Zach. I'm going to launch the poll for everyone to answer. In addition to food and beverage, which we do ask you to check, what other industries do you work in? We're going to let this go for at least 20 seconds or so to make sure everyone has a chance to answer. And now we will close it and show the results. So wow, okay, so half of you guys are in food and beverage and half do oil and gas as well. So that's great. We definitely have solutions for both of those industries, clearly. we'll have these results, and Zach, you should be back up and going.
Okay. All right, so there's a number of industries. The air seal is essentially a concept that can apply really anywhere where air is allowed in a vessel. So pulp and paper is a very common industry, and actually there's a ton of overlap with food because there are FDA requirements in the pulp and paper industry with paper mills that make packaging for food, actually. So it's a very, very common overlap industry. Something that's also big in paper is that has parallels to the food industry is much of the vessels are moving a slurry of paper. They call it pulp, and that pulp is very similar in concept to just any type of slurry food. So if you had say for an example, a blender blending oatmeal, it would be a very similar application to paper, and we use that seal across these industries. Cement would be analogous to dry powder. So if you had sugar, flour, salts, any of those types of applications, seasonings, you could go on forever with those. The dry powders as well is something that it sells. And then gypsum would be another one that falls under the same category as cement because it's a lot of dry powders as well. Okay, so some in the there's a number of successes that we've had, a variety of successes across different areas of the food industry. One such is bread, which would fall under the powders. Typically, you're dealing with flour and fortification seasonings, whatnot, and oftentimes when they leak, they also create the bacteria issues and build up around the shaft, which increases the need for cleaning. So if you look at that top left-hand image, or the furthest image on the left, that is for a bread mixer. And what was happening with there, and that's an actual air seal installed there. What was happening before the air seal was there was the bread ingredients they'd cake up around the stuffing box, and the bacteria would form, and you'd end up with flies around it. So what the air seal did was keep them away. Rotary airlocks are another common application. They're more of an indexing. I'm not sure if everyone's familiar with rotary airlocks. They're in most food. They're in most dry powder industries, and it's basically an indexing delivery system. And we use air seals on those as well. Ribbon blenders is another application, and the list goes on. It's essentially any vessel moving a product that would leak out of a stuffing box any shafted vessel moving a product. Next. So bread mixers are, not everyone eats bread. I shouldn't say that. There's a lot of low carb people out there and gluten-free people out there, but it's still, the number one recommended on the food pyramid still. So it's a very, very big industry. There's a number of issues that destroy the packing. So essentially the bread would work its way out of the packing, but it would also embed itself in the packing. And I'm not sure if everybody 100% of you click packing, but I'll just use this as an example. So here's an actual piece of packing right here. Now it's black. You wouldn't use that in the food industry. You'd use white. But what happens is the powders would essentially embed themselves in the packing, and it forms almost like a little sandpaper or saw, whatever analogy you would like to use, that actually starts to score the shaft. And that goes back to the beginning when we discussed the leak paths created by contacting seals. One of the reasons for that is because it would allow embedding of the product into it. Okay, and then next. All right, so some of the issues are obvious. Safety is a major issue. That alone justifies the air seal because safety is one of the biggest. Every plant in the world says safety first. and it's obviously very important. Sanitation as well. You really don't want the FDA snooping around. And then product loss is sounds secondary, but when you start losing, a good 10, 20, 30% of your product through leakage, it really cuts into the bottom line. And it also creates a need to have constant cleaning, which is another additional cost. And of course, there's premature bearing failure. And what would happen there, the reason there would be premature bearing failure is when product leaks out, it goes into the environment, and adjacent to any shaft, or at the end of every shaft, rotating shaft, is a bearing. Now, if ingredients get into the oil of the bearing or the grease of the bearing, it degrades the bearings over time and creates wear. And then as those bearings wear, the shaft starts to move more, and it creates an issue there for reliability of the actual equipment itself. So the non-contacting air seal, what it does is it solves all of these problems. So it sealed the mixer without any shaft wear at all. And so what we've essentially accomplished is a seal that runs permanently because there's no contact, there's no wear, and from that resulted in no additional maintenance, no additional cleanups. The only thing that needs to be maintained is air pressure on the actual seal. So in a lot of ways, it's a set it and forget it type of seal that provides tremendous value long run to the customer. Okay, is it going? Next slide. Oh, you got it. Okay, same picture. Sorry guys, I was staring at the picture. So there's a number of other things that were saved. So the bacterial growth, which I kind of touched on earlier, the money saved, the weekend maintenance, which is nobody wants to work weekends if they don't have to, and then the operation since the installation is it's still running today, and this was put on years ago. Okay, now we're moving to the candy industry. It's a little more fun than bread. Rotary airlocks are something that we've sealed up in the candy industry, and everybody familiar with rotary? I don't know if anyone can answer that, but type in if this is a common application. Type into the questions.
Zach, yeah, if you want to type in the question section, if you have worked with rotary airlocks or if you are familiar with them, we'd appreciate it.
Okay, so the airlocks we use, they were used as feeders in this application that we're looking at here. They're used as feeders to move dextrose from sugar silos and mixers making peanut butter. The lip seals, which is what they were currently using, and I know half of you said you're using lip seals. The lip seals are basically just literally a rubber lip ring that go in the stuffing box bore, and over time that rubber wears the shaft and the shaft wears the rubber, and then the leak path is created by that as well.
And just a real quick, we did have one person say they have not worked with rotary airlocks. So if there's any other detail you'd like to share about how they work, that would be great. Otherwise, I'll move to the next slide.
Okay, yeah. So basically, a rotary airlock is an indexing. It's a rotating application, and it indexes and delivers a certain amount of product to the next stage of the production, right? So if every batch of peanut butter needed, to say 12 ounces of sugar, I just made that up, that could be any number, the rotary airlock would deliver 12 ounces in the interval required to match the intervals that the peanut butter was being put in. So it would just essentially an ingredients delivery system. It's an automated ingredient delivery system. Slide. Okay. initially, when we saw this application, sugar was everywhere. You couldn't avoid it. It was like a winter wonderland. If you walked in it, it would be up to your ankles. And so that's clearly a major issue. And then it also, another thing, this is actually really important, is it's not only the equipment itself that you're protecting, but you're also protecting the equipment around it, because as the product leaks out, as sugar leaks out, it gets everywhere and it goes into other applications and creates damage to motors, motor bearings, gearboxes. Anything that's in the air is susceptible to the leakage and susceptible to the consequences of the leakage. Of course, there's also safety issues. You could slip and fall on it, and then that creates I mean, you don't want anyone getting hurt for any reason. And then sugar dust actually creates static electricity. And it's not just sugar dust. There's a number of dry powders that do this. They create static electricity, and they are a fire hazard. And so that's another major safety issue that's absolved by the air seal. Okay, in this application, the air seal replaced a lip seal, and they've been running for 12 months now, which is just very impressive. But essentially, they run for as long as the bearing lasts, and they make the bearing last significantly longer by not allowing product into the bearing. Okay, so they went from constant product loss, constant maintenance issues, and housekeeping issues down to nothing. So essentially what happened is we put the air seal on, they sort of set it and forget it. Now, sometimes you'll see in our pictures of an air seal, you'll see product around it. That's because it's coming from somewhere else oftentimes. So this particular picture, you could see it's coming from above because it's all on top of the air seal, but where that arrow is pointing is where the air seal seals from. So and as well as the back of the gland forms a gasket against the housing, so it won't leak out there. So the product will never leak out of the stuffing box. So I just wanted to note that in that picture there. Next one. Okay, now we'll talk about ribbon blenders. Honestly, it's the same solution for and the same problems almost with all these applications. The applications only differ in their design and their function in the food processing. Now, so same thing, it was product loss, housekeeping, and safety issues with the blenders as well. Next slide. Okay, so anytime something leaks, that's dollar signs, and they lose money. Whether it's the product itself, whether it's the equipment failing, whether it's the maintenance or the cleanup that goes with it. All right, here's an air seal on a ribbon blender. I actually installed this one, and I'm looking at it. I installed this one myself. It was constantly, this was at a seasonings plant, and it was constantly leaking everywhere, all those issues that we had discussed. And this is actually a great view because you can also see the bearing on the left-hand side, and you can see how close the bearings are to the actual equipment. If you look at that, imagine sealing that with lip seal or packing or mechanical seal where the product would leak out into the bearing. And there's actually like a trough below there where the product could actually pile up and surround if it happened too fast and they didn't get on it in time, which is very, very commonplace because a lot of this equipment's covered up and they're not watching it 24/7. So in this particular case, this was at a food plant or a seasonings plant in Pennsylvania. We've eliminated the product loss 100%. They really haven't gone back to this equipment since this seal has been installed. Next. And now we're open for questions.
Okay, Zach, let me hop in. And remember, you can continue to ask questions throughout the rest of this Q&A, and we will get to them when we can. I do have the first question is, you've talked about mixers and and ribbon blenders and chocolate conches and things like that. Is there an air seal for use with pumps?
Yes, yes. Typically slurry pumps, as long as the pump allows air into the process, then yes. So I would use it on slurry pumps more than like water or less viscous fluid pumps.
Right.
But yes, it's very, very common on pumps as well. And pumps run through the same issues as mixers, agitators. They're a little bit more tightly tolerant because they're much smaller and more compact. So the shaft movement isn't always as bad, but you have many situations with pumps, you have them installed on uneven ground or soft ground, and or pipes are not led to them properly, so they'll have pipe strain that'll cause movement in the shaft, and the air seal comes in there. When there's any shaft movement on a pump with slurries, is a very, very common application where the air seal can solve all those same issues that it solves for the other applications.
Okay, and one more question. So, our poll that we had, not very many people, well, no people said they were using, none of our attendees said they were using air seals. So how long have air seals been around, and why aren't they more widely used?
Air seals have been around for about 15 to 20 years, maybe a little bit longer now. It's sort of it's a startup product, and it's a lot of times they're not used because nobody's talked to anybody about them. That's probably every time I talk to someone new about an air seal, it's the first time they've heard about air seals. And then there's a process of, it's a new technology, so there's always that initial questioning of it. But once they're used in a plant, they tend to be used often more times after that. They just keep calling back for more. And frankly, prior to Lori DeTuro coming to SEPCO, we weren't doing webinars like this and advertising as we should have. So they were used by the people that outside people like myself just went and talked to in person. So that'd be another reason.
We have a question that just came in. How hard is it to determine the proper amount of air, and what happens when or if too much air is applied?
You're really not going to have much issue if too much air is applied. You might whistle a little bit more. You determine the air pressure requirement based on the head pressure of the product, and you just have to exceed the head pressure of the product. So let's say you were just mixing water, or not water, but just any ingredient. The weight of that ingredient on pressure on the air seal would just have to be exceeded by the air seal. All you're doing is creating a pressure differential. And once you've created that differential, the air seal will function as needed. And I go 5 psi over to be safe, to create a buffer. But the air doesn't really, if you put a lot of air on it, it's fine because it builds a back pressure, and there's only so much that'll relieve itself. It'll only allow so much through.
Okay, so you said that it's non-contact, and I know that it requires very little, if no maintenance, but if the air is turned off, or if something were to fail or go wrong, what are things that might cause an issue with an air seal?
Well, the number one issue for air seals is lack of communication in a plant, because it's a newer technology. So as people could walk by it and hear air running and think the air shouldn't be running and turn the air off. It sounds silly, but that's literally the most common that I've dealt with. Hey, we shut the air off. Now, that said, in a number of applications where this has happened, they turn the air back on and it's sealed again. Worst case scenario was if you have a super highly abrasive product, it could embed itself. But even then, I mean, it's very rare for that to happen. Typically what I do when that happens is I either go to the plant or consult with the plant about taking the throttle out and observing it for damage. And if it's clean, if it's good, you just clean it and put it back in. Our applications, our air seals are very commonly split. So this is an issue that can be solved very easily. the split seal allows it to be disassembled at the actual application, as opposed to having to decouple the application to take it apart. And also, the worst case scenario is that you would have to replace the throttle, which is very easily replaceable, and it's only a portion of the cost of the seal.
And that need to replace is fairly rare. Is that correct?
Very rare. Like, I mean, I don't know that I've done it personally. I know that we've done it as a company for a few applications where that's happened, but it's very, very rare.
Okay, so this is a very specific question from one of our attendees. I have a customer who tells me they are currently using Impro air seals. How can I combat that, and how is the Sepco air seal a better option?
It's better option for a few reasons. One is our throttle delivers the air differently. It delivers it in a more efficient manner. We have tighter clearances in the actual air seal itself. And then the other thing that you get with us, aside from cost, our cost of manufacturing is significantly lower than Impro, so our savings are passed on to the customer. But I never like to just discuss that, because that doesn't go into the merits of the seals. What we have at Sepco that really separates us from anybody else, I mean, really, Impro is really the only other company that does this type of air seal, is our engineering team, which actually came from Impro. That they were actually like an original generation of Impro engineers that we have at the Sepco team that were at the forefront of their air miser. And as Impro was purchased, they moved by a major company. They moved away from their custom engineering that we've now adapted into Sepco. So I almost want to say it's our engineering department that sets it apart, because of the flexibility that we have with our designs and the willingness to accommodate different applications that might not be accommodated elsewhere.
Okay, I think that is our last question. If another one comes in while I'm wrapping up, I will certainly stop and ask that. But thank everyone for joining us. Remember that there are 3 handouts in the sidebar of the GoToWebinar side control panel, or sidebar, whatever you want to call it, that you can download. Thanks for joining us again. We will send you the recording and a copy of the slide deck sometime tomorrow. And please mark your calendars for September 21st. Because we will be having our next Seal Connect webinar then, and it will be presented by the editor of Plant Services, Tom Wilk, and he will be talking about predictive maintenance and a survey that they conducted around predictive maintenance trends and things that can help plants solve downtime and reliability issues. And he will also talk about ways that you and other industry experts can submit content to Plant Services, and you can become a writer for them as well. So we will be having a webinar with Tom Wilk from Plant Services September 21st. So please join us then. And Zach, thank you again for presenting today. And Zach's email is on the screen. So if you have any further questions, feel free to reach out to him, or you can reach out to me. My email is in your webinar invitation, so you can reach out to me if you have any questions. Thanks again for joining us. And Zach, thank you again for presenting.
Thank you all. Thank you. Take care.
Thanks. Have a great day.